So when you take a look at doing this problem, the first thing I want to do is I want to look at the equation and figure out what the various transformations are. Well, the minus 5, it's the number that's subtracted inside the parentheses. It does what it's always done, which is move it right 5. The minus 4, hanging on the end, does what it's always done in the past, which is move it down 4. So already I know that my first point, my vertex, because this is called vertex form, is at 5, negative 4. But what about the 1/2? What do we call the 1/2?
What?
All right, and so yeah, the 1/2 is a vertical compression by a factor of 1/2. So it's squishing our graph in from the top and the bottom towards the axis there. All right, now what that means for our graph here is that instead of going up 1, I'm only going up 1/2. And instead of going over 2 up 4, I'm going to go over 2 up 2, because half of 4 is 2. And then instead of over 3 up 9, we're going to go over 3 and up 4.5, because half of 9 is 4.5, and so on. And we just keep plotting points like that, taking whatever I normally go up and cutting them in half. You then get those points and that graph drawn through it. Now, some separate questions here. Just kind of bring back some of this. You don't need to write this stuff down, but you can if you want to. The transformations, the 1/2. I just talked about it. Do you remember what we called that?
Compression.
Yep.
Oh,
A vertical compression by a factor of 1/2. And of course, the shift right 5 and shift down 4. Remember, yes, you do need a verb in there. So yes, say it's a shift or a move or a translation, whatever. Vertex. The vertex we can actually read out of our original equation because it's going to be at a positive 5 and a negative 4. Or you could look over here at your graph and you can spot it out of there. And so what is our range going to be then? Remember, range is always dealing with y, right? What's my starting y value? Negative 4. And then does it go up or down from there?
up.
Hence greater than or equal to. And remember, that's how we build our range. All right, so having done that, we're getting pretty comfortable with these. So now today we're going to extend into some of the slightly trickier parts or things that might get maybe a little bit messier. Starting with combining the vertical stretches and compressions with standard form. So you basically have all the tools for this. You might hit a hiccup here or there. If so, we'll deal with it as it happens. But go ahead and start graphing this one using the same methods what we saw when graphing standard form before. As soon as you see standard form and you know you need to graph it, I hope that your mind automatically goes to x equals negative b over 2a. If you're going to graph from standard form, you have to use that formula. So we know our vertex is at 5,8, so that's the very first thing we do is on our graph, we go over to 5,8, plot that point. And then, all I need to know from here is that the a value is negative 2. Now that actually is telling us two different things. The negative tells us that it's going to be opening downward. The 2 tells us that we're going to have a vertical stretch by a factor of 2. So instead of going over 1 down 1, we're going to go over 1 down 2. And instead of over 2 down 4, it's over 2 down 8. Because however far we go up or down, I'm doubling it here because of that 2. And then over 3 down 9 becomes over 3 down 18, which, yes, just barely fits on our graphing grid. And so you plot those points, and then draw your curve neatly through those. Now, having done this one, we can handle this pretty well, but we had a nice, pretty number in there for A. It was something that was easier to plug in, and I want us to be able to see how to deal with the ones that aren't quite as pretty. So that's what we're going to be dealing with on this kind of a problem. So we're going to see how to find the vertex when our A value is a fraction.
Oh, come
Now,
on.
the good news is, I'm not going to make you graph this one. We're just going to figure out where the vertex is. Because I know that if you knew where the vertex was, you could make the graph.
Yeah.
So, write down this equation, then we'll walk through it together. Now, since we're finding vertex, I hope that your mind is immediately going to a short little formula.
No.
Because whenever we're going to try to find the vertex from standard form, we should be using negative b over 2a. And so that's what we're going to do here as well. We're going to use x equals negative b over 2a. It's just that in this case, my b is a negative 6 over 2 times a is 1/3. Now, some of you kind of want to cry a little bit inside because we have a fraction in a fraction. But the good news is that if you're a little rusty on your fractions, I'm going to start, at least for this one, with a quick review about how we deal with it. Now remember, order of operations and dealing with these, the very first thing we do is we multiply those two numbers in the denominator. That means I need to do 2 times 1/3. Now if you're a little rusty on that, the first thing we do is we turn this both into a fraction, so it becomes 2 over 1 times 1/3. And then to multiply fractions, we multiply straight across the top, 2 times 1, and straight across the bottom, 1 times 3. And so that equals 2/3. So then, that's why I know that this whole thing equals a negative 6 over 2/3. Okay, so the next thing is we now need to do the negative 6 over the 2/3. Well, and if this gives you trouble, again, a little bit of a refresher here. Remember that a fraction is the same thing as division. And so I could rewrite this as negative 6 divided by 2/3. And if I'm going to do that, again, I can turn the negative 6 into a fraction, so negative 6 over 1. And then division of fractions, this is the one where, yeah, we flip and multiply. Or if we want to actually use the technical words, we're going to multiply by the reciprocal. So the division becomes multiplication, and we flip the second fraction. Always the second fraction. Notice that the division becomes multiplication, and we flip the fraction at the same step. It is not two separate steps. It is all one step. And then once we've done that, then it's just multiplication. So negative 6 times 3 is a negative 18. 1 times 2 is 2. What does negative 18 over 2 equal?
9.
Negative 9.
Told you it was negative 9.
And so we end up finding then that x equals a negative negative 9, which is just positive 9. Okay, now that we know the x, you know how to find y. Plug it back in. So go ahead and plug that 9 back in for x and see what it gives you. And so to figure out what y is, we plug the 9 in for x into our equation. And then from there, we go ahead and we square the 9 first. Remember, exponents first. Then multiply that by 1/3. Same thing as dividing by 3. And then we go ahead and we do the addition and subtraction, left to right, remember. And that ends up giving us y equals negative 7. Therefore, final answer, the vertex is at 9, negative 7, which if we were graphing it would then be enough information because you know you'd start at 9, negative 7, and then you'd have a vertical compression by 1/3 from there. So we worked through that last one together. You've seen how the basic process goes, so you know how to do this one now. Go ahead and start working it through on your own first, and then kind of check in. I'll be putting the work up here so you can check as you go. You'll notice in this one actually it ended up working out pretty well because when we went to actually multiply in the denominator, the 2 times negative 1/2 is just negative 1. That one worked out to be a nice pretty number, so we didn't have to divide by a fraction. We were just dividing by negative 1, which made our life easier. Now that you found the x, yeah, go ahead and find the y. And so when all's said and done in this one, you should have gotten an answer of 4, 1. And so again, this means that we could then graph this based on this information. You don't have to graph it now, but we had put our first point at 4, 1. And then notice we have a reflection across the x-axis to make it go upside down, and the vertical compression by the factor of 1/2. And so it would be going down half as far as what you normally would. So from here, that means we actually have to do that multiplication on the bottom. We have to do 2 times 5/4. And remember, in order to do 2 times 5/4, that means turn it into 2 over 1 times 5/4, multiply straight across the top, multiply straight across the bottom. Now, you can go ahead and leave your number here as 10/4. It's not going to change anything in the final answer about how you do it, but I'm a creature of math habits, and so I always reduce my fractions whenever I can, so I'd call it 5 over 2 as I put it in there. All right, then at this point, we have to do the negative 10 divided by 5/2. And remember, in order to do 10 divided by 5/2, that means I write it as 10 over 1, and I multiply by the reciprocal, which gives me 20 over 5, and of course 20 over 5 equals, there's our x value. So when all said and done on this one, you end up with an answer of -4, -3. Now, a little side note on this one, though, because in this case, what if we went to graph it? You would put your first point at -4, -3, but then where would you go from there? You go over 1 and up
5/4.
5/4, like 1 1/4 there. What if you went over 2? You'd go up, well, you'd have to do 5/4 times 4, which would give you 5. And you'd have to go through that process. Notice the 5/4 here. Would that then be a vertical stretch or a vertical compression?
Compression. I think definitely.
If I multiply something by 5/4, does it get bigger or smaller? It gets bigger. Therefore, stretch. Because it's a top-heavy fraction, yes, it is a stretch. All right, so our two numbers end up being -12 and 6.